Good evening, children. This is errors finding notes, Nana. Hope all of you written the examination very well. Errors finding notes means in examination, whatever the mains model or advanced model examination, whatever the questions you missed in the examination, means you left the question or you did a mistake in the examination, Nana. You have to write the solutions of those questions in errors finding notes, Nana. Okay. Today we have written a mains model examination, Nana. Solutions for the chemistry part, Nana. All of you open your errors finding notes and question paper, Nana. Question paper. Here, question number 26. In van der Waal equation of state for non-ideal gas, the term that accounts for intermolecular force, Nana. Intermolecular force represents P plus A by V square, Nana. This is a pressure correction. Here A represents intermolecular forces, Nana. Significance of A. We discussed that in van der Waal equation, Nana. B represents gas molecule. A represents intermolecular force, Nana. Question number 27. A, van der Waal constant A is maximum for, Nana. We discussed that, Nana. NH3 among the given molecules, Nana. NH3 more than oxygen, more than hydrogen, more than helium, Nana. So here maximum for ammonia, Nana. Question number 28. Here different gases, van der Waal constant A values are given, Nana. Look at this. Here O2, N2, NH3 and CH4. 1.360, 1.390, 4.170, 2.253 liter square ATM per mole square, Nana. Here are different values, different gases A values are given, Nana. A value increases, liquefaction increases, Nana. A value increases, liquefaction increases. Look at the question. Here the gas which can most easily be liquefiable. So which has more A, that easily liquefiable, Nana. Is it clear, Nana? Question number 29. Question number 29, that is conceptual, Nana. Look at this, which is not true in case of ideal gas, Nana. First statement, it can be converted into a liquid. It cannot be converted into a liquid, Nana. So your statement A is correct. There is no intermolecular attractions between the molecules. Your B statement also correct. All molecules of gas move with the same speed, Nana. Here this is a false statement, Nana. Here average kinetic energy of the molecules is same, Nana, but the gas molecules, each molecule has its own velocity, Nana. Means all molecules do not move with the same speed, Nana, but here move with the same speed. That is given, Nana. C, option C is a wrong statement. At a given temperature, PV is proportional to amount of the gas. PV is equal to nRT. From that we can understand this. So A, B, D, three statements are correct. Your third statement is a false statement. Question number 30. A gas will approach ideal behavior. This is also conceptual, Anna. Here a real gas approaches ideal gas, Nana. Real gas approaches ideal gas. Here at a high temperature and low pressure, Nana. We discussed HTLP. HTLP means high temperature and low pressure, Nana. Question number 31. Nana. The temperature at which real gas obeys the ideal gas. Here boils temperature, Nana. Boils temperature statement. Once look at the statement, Nana. The temperature at which the real gas obeys ideal behavior, Nana. Means ideal gas laws over a wide range of pressure is called Boyle's temperature. Question number 32. Here a normality of 10% mass by volume of acetic acid, Nana. Here normality, look at the formula, Nana. Normality in terms of weight by volume percentage, Nana. Weight by volume percentage into 10 by gram molecular weight. This is the formula, normality formula. From the given data, here weight by volume percentage is given. Here acetic acid, Nana. Acetic acid gram molecular mass, Nana. CH3COOH. Here 24, 32, 4, 10, 16, Nana. 2 carbon atoms, 24, 2 oxygen atoms, 32, 4 hydrogen atoms, 4. Total 60. If you substitute the values, Nana, gram molecular weight of acetic acid 60. Here weight by volume percentage 10 into 10 by 60. That is equal to 1.7 N. Normality of 10% weight by volume of acetic acid is 1.7 N. Question number 33, Nana. There 250 ml of 0.25 m NaCl solution is diluted with water to a volume of 500 ml. Here according to law of dilution, Nana. According to law of dilution, M1 V1 is equal to M2 V2, Nana. That is the formula, law of dilution. Here see the data. M1 is given as 0.25, V1 is given as 250 ml, M2 is to be identified, Nana. Here V2 is to a volume 500 ml. When we substitute these values, you get M2 is equal to M1 V1 by V2, Nana. That is equal to 0.25 into 250 by 500. Here 250 2 times, 250 by 500, 2 times. Here 0.25 by 2, you get M2 is equal to 0.125 M. According to law of dilution concept. Question number 34. Volume of 0.2 N base required to completely react with 0.5 liters of 0.1 acid, Nana. 1N acid. Here at neutralization, Nana. Neutralization. Neutralization concept nana. Milli equivalence of acid is equal to milli equivalence of base nana. Normality into volume in ml, normality into volume in ml. This is for acid, this is for base. Here what is the data given? Look at that. Regarding base 0.2 n, volume you have to identify. Regarding acid, normality 0.1 and volume is given as 0.5 liters nana. 5 liters is equal to 0.2 into volume of base. From this you get volume of base is equal to 0.1 into 0.5 by 0.2. You get 0.25 liters volume of base. Is it clear? Question number 35. Volume of 0.0525 m phosphoric acid required neutralization. Again same concept at neutralization. At neutralization concept. Here molarity of acid into n factor of acid into volume of acid. No change nana. Here normality is written as molarity into n factor. No change. Here normality is written as molarity into n factor. That's it. So molarity of base into n factor of base into volume of base. Look at the data. Molarity of acid 0.025, n factor of H3PO4 nana. Phosphoric acid is 3, and volume you have to identify. Regarding base 0.03 m. Calcium hydroxide nana, n factor value 2 into volume is 25 ml. If you simplify this, you get the volume of acid is 20 ml. Volume of acid is 20 ml. Question number 36 nana. Increase in temperature and aqua solution will cause. Here temperature dependence nana. Look at this. Here molality, mole fraction and weight by weight percentage nana. Among these, this is temperature independent nana. Because in these three cases, in the formula of molality, mole fraction and weight by weight percentage, there is no volume term. So these are all temperature independent. This is a temperature dependent. That too, molarity is equal to number of moles by volume. So here volume is directly proportional to temperature. Molarity is inversely proportional to volume. So molarity is inversely proportional to temperature nana. From these three relations, we can understand molarity is inversely proportional to temperature. Here, temperature increases, so molarity decreases. 37. Here, molarity of 7.1 grams of Na2SO4. Here, molecular mass, formula mass also given. Enough water, 100 ml of volume is given. Simple statement. Here molarity is equal to weight by gram molecular weight into 1000 by volume in ml. Here all the data given. Weight is given, gram molecular weight is given, volume also given. Substitute the values. Weight is 7.1, gram molecular mass is 142. That is also given in the question. 1000 by volume is 100 ml. Here 10 times 10 into 7.1, 71 by 142, 1 by 2, that is 0.5 m. Molarity of the given solution is 0.5 m. Question number 38. Which of the following solution has highest normality? Nana? If you identify, look at first option. Nana. Normality of 8 grams of KOH per liter. Nana. That is the first statement. If you identify normality here 8 grams of KOH molecular mass 56 into 1 nana, into 1 by 1. Weight by gram molecular weight into 1 by V in liters nana. Here per liter 1 liter is given. This is 1 by 7. Second one nana. N means normal H3PO4. Here normality is given as 1 nana. 1 normal. Option C. Six grams of NaOH per 100 ml nana, not in 1 liter. If you identify normality is equal to here 6 by 40 into 1000 by 100 nana. Weight by gram equivalent weight into 1000 by V in ml. Okay na? If you simplify this, you get 1.5. Here fourth statement. .5 m H2SO4 nana. If molarity and molality both are taken as equal, even if you take equal value nana, you get the value is 1 nana. Here molarity is 1, normality is equal to molarity into n factor, molarity 0.5 nana, 0.5 into n factor of H2SO4 is 2, then you get 1 only. So among these, here 1.7, here 1, here 1.5, here 1. So among all these 6 grams of NaOH in 100 ml has the highest normality. Actually molarity and molality both are not equal nana. If you calculate actual molality, you get 0.47 something value nana. Even if you consider equal, you get 1 only. Is it clear nana? See question number 39. Here 100 ml of 0.3 NHCl is mixed with 200 ml of 0.6 NH2SO4. Here law of mixing nana. According to law of mixing, NR is equal to N1V1 plus N2V2 by V1 plus V2. First case nana, normality 0.3, volume 100 ml. Second case normality 0.6, volume 200 divided by 100 plus 200. If you simplify this, 0.3 into 100 30, 0.6 into 200 120, total 150 by 300 1 by 2, you get 0.5 N. Question number 40. Ideal solution conditions nana. Ideal solution conditions. Ideal solution conditions nana. Here first one, obeys Raoult's law. Second one, delta H is equal to 0 and delta V is equal to 0. Nana. These are the three conditions. Check it, Nana. Here have both zero heat of mixing as well as zero volume change. Both conditions, Nana. It should satisfy both the conditions. 41. Here, which of the following pairs will not be form ideal solution, Nana? Here, ideal solution examples, Nana. That is given in the class notes, Nana. Once check it. Examples. Here, NaHCN and heptane, ideal solution. Benzene and toluene, ideal solution. Ethyl bromide and ethyl iodide, ideal solution. Here, acetone and chloroform, Nana. These are the non-ideal solution. That too, this is a negative deviation, Nana. Question number 42. Which of the following pairs show negative deviation? Here, negative deviation. Acetone and chloroform, Nana. Acetone and chloroform. That is a second option, Nana. Look at acetone, benzene, acetone, ethanol, benzene, methanol. These are all positive deviated solutions, Nana. Here, acetone, chloroform. Before mixing, no attractions. After mixing, attractions, Nana. Question number 33. Here, benzene and toluene, Nana. Benzene and toluene, they can form ideal solution, Nana. No deviation, Nana. Look at that. Positive deviation, negative deviation, practically no deviation, irregular deviation from the Raoult's law. Here, no deviation observed. No deviation means it become ideal solution. Is it clear? Next, question number 44. Molarity of 0.2 N Na2SO4, Nana. Here, molarity is equal to normality by N factor, Nana. Here, the solute is Na2CO3, Nana. N factor value 2. Salt, N factor value 2, Nana. 2 Na plus CO3 minus 2. Magnitude of the charge on cation or anion, you get 2. Normality is given as 0.2, N factor is 2, then you get 0.1 M. Molarity value 0.1. Question number 45, molarity of pure water, Nana. Pure water. Based on the molarity statement, Nana. Number of moles of solute per liter of solution, Nana. If you consider 1 liter water, here the weight of water you get 1000 grams, Nana. Due to density of water is 1 gram per ml. Here 1000 ml, 1000 grams, Nana. Density, mass is equal to here volume into density, Nana. Okay, na? So here weight of water is 1000 grams. Number of moles of water is equal to 1000 by 18, Nana. Molecular mass of water is 18. Then you get 55.5555. It is approximately taken as a 55.6, Nana. Moles per liter, Nana. Number of moles per liter. That is a statement. Question number 46. For any gas boils temperature, the value of compressibility factor, Nana. Here Z for ideal gas, Nana. Ideal gas is equal to 1. Here question is indirectly given, Nana. Boils temperature. Boils temperature means the temperature at which real gas approaches ideal gas. Ideal gas Z value 1 only. Compressibility factor. 47. Excluded volume is how many times of the actual volume, Nana. Here van der Waals constant B, Nana. That is 4 times of actual volume. Here this is the relation discussed in the volume correction. B is equal to 4 times of actual volume of molecule. Question number 48. The number of components in ternary solution. Ternary solution. Ternary solution components. Number of components is equal to 3. Ternary. Binary solution 2. Ternary 3. Quaternary 4. We discussed the types of solutions. Question number 49. The sum of the mole fractions here chi A plus chi B is equal to 1 for binary solution. Binary solution means only two components. One is solvent, another one is solute. Mole fractions of all the components is equal to unity. Question number 50. 1 gram mole of oxalic acid dissolved in 2 liters of solution. Concentration of solution in normality. Normality is equal to here number of moles into n factor by volume in liters. General formula is what? Normality is equal to gram equivalents, number of gram equivalents per volume in liters. Gram equivalents is nothing but moles into n factor. Here look at this number of moles. 1 gram mole is given. Here oxalic acid H2C2O4 n factor value is 2. N factor value 2. So here moles 1, n factor value 2. Here volume is given in 2 liters. So here normality you get 1. Is it clear, Nana? Okay. Thank you. Thank you, children.